Hello, welcome. Let's try to solve another Leetcode problem. 745 prefix and suffix asserts. So for this problem, I'm gonna write the code from scratch. It's gonna be a lot of lines of code. It's gonna be 50 lines of code, but basically I'm gonna build a template structure, and then I'm gonna try to use the method to solve the problem. So you don't need to take care of all those code I've written, because I will post it in the GitHub, and I'll post it in the I'll post the link in the YouTube description for this problem, and you can check that. So we don't need to take care so much of the code. We just need to take care about how to solve the problem. Basically, it's a prefix and suffix asserts, and we are giving a word filter, and it has an array of words. There's only one example, but definitely it's gonna have an array of words. So for example, the first one maybe apple or maybe A, the second one maybe B. So it's gonna be an array of words. We want to find let me just delete this area. So we want to get this function f. So f is the string prefix and suffix. So this means inside the example, for this example, if we are having a capital A, so this is going to be a prefix. So we're going to find the index for the prefix, but we're going to find the largest index. Currently, there's only one word, so the index is going to be 0. And for this E, the index is also going to be 0. We just need to find one word. It has the prefix and the suffix. So for this word, it has both A and E as prefix and suffix, and its index is 0. So we're gonna return a 0. Maybe there's another word, maybe ape. It is the second word. It also meets the condition. So the prefix is A, suffix is E, but the index is 1. So we're gonna return 1. Because if we can find it, both has the suffix and prefix, we're gonna return the largest index. As you can see from here, return the index of the word in the dictionary, which has the prefix pref and suffix surf. If there's more than one valid index, we're going to return the largest of them. So this is 0, this is 1, we're going to return the largest of them. If we cannot find it, we're going to return a -1. So this means if we want to find maybe A and D for this apple, definitely we cannot find it. So we're going to return a -1. Now let's focus on how to solve the problem. So while we are checking the prefix, it is okay, and we can use the prefix tree. But what about the suffix? So because this E is just the suffix, and we can reverse the word and use the suffix tree. So for example, it is apple. We can prepare the tree. We can reverse it like EL, and then we're gonna reverse this search. If this is E, we're gonna reverse it. So for example, if this is LE, we're gonna reverse it to EL. And this is EL, and this is EL. We can use prefix tree to solve the problem. Now the problem becomes easier. We're gonna use the prefix tree to solve the problem. But there's a lot of details, so I'm gonna consider that in my code. First of all, let's just prepare a prefix tree. Let's prepare a trie. So I'm gonna define a trie node. So inside of the trie node, definitely I'm gonna init the trie node, and inside I'm gonna the basic template for trie node. I'm gonna have a children. So self.children. It's gonna be a dictionary, and then I'm gonna have self.add of word. So the add of word gonna be false from the beginning. Now I'm gonna prepare the trie. So this is just the basic template. I'm gonna change it later to accustom to our problem. So I'm now gonna prepare a trie. So the trie, I'm gonna init it. So inside I'm gonna prepare a self.root because I will use it later. It's gonna be the just the trie node. The trie node. I want to use the basic method. It's gonna be the insert. Basically, it's gonna be insert a word inside of the trie. So I'm prepare the current, it's gonna be the self.root, and then I'm gonna enumerate the character inside the word. So if this word not inside the current dot children. So if I'm checking this word, I'm gonna insert it. So if this word is not inside of the dictionary, because self.children and current.children, it is a dictionary. If it is not inside, what I'm gonna do? I'm gonna build a new one. Yeah, so I'm gonna build it. So the my current gonna be try node. Yeah, so if it is not inside current.children, so current gonna be, yeah, I did something wrong. So current dot children with C. Yeah, so if this character C is not inside current dot children, not inside of the dictionary, so I'm gonna prepare this character. So current children, this is the dictionary. Inside of the dictionary, I'm gonna prepare a K. K is my current character, it is a C, and then I'm gonna prepare the trie node. Yeah. So if it is inside, so the current should equal to current dot children, and with this character, we just need to shift it to the next character. Yeah. So this is the insert. Finally, I'm gonna return current dot. I don't need to return anything. I just need to get current dot add of a word, set it to be true because I'm sure this is gonna be the add of the word. And then I'm gonna use another method. It's gonna be the prefix. So the prefix it's gonna be the same structure. Let me just copy it and change a little bit to finish the prefix. Yeah, so the prefix I'm gonna prepare a current. It's gonna be the self.root, and for C inside of the word, if C is not inside, so I can return a false immediately. So otherwise, current should equal to current.children with this character C, and finally I'm gonna return true. Yeah. So this is the basic structure for a trie. We have trie node and we have trie, but it cannot be used directly to solve the problem. So I'm gonna change the structure later. Yeah, basically I need to change a little bit to fit to our problem. Yeah. Now for our problem, let me do some pre-process of the problem. Yeah. So we have the words, but we need to get the maximum index of the words. So for example, if we have a duplicate of words, like we have a, all with the words, this is index 0, 1, 2. We don't need to have those 0 and 1 because we need to get the maximum index. You need to understand the problem. Yeah. So we don't need to have those AA. We only need to have the third A. It's gonna be index 2. Now we're gonna prepare a dictionary to solve this problem first. Yeah. So I'm gonna prepare a dictionary. D should be equal to default dict with integer, and for word, yeah, I'm gonna use enumerate. So for I word in enumerate the words. So this dictionary with the word, I'm gonna store the maximum index, so I can directly use it for the index I. Yeah, so this is just a pre-process for the words. Yeah, now I have a dictionary. It stores the largest index. Yeah, basically I can remove the duplicate words as well. Yeah. Now I want to prepare self.trie. So self. Let's use T1 and t2 maybe. Yeah, self.t2 should be equal to try. Another one gonna be try. We need two try. One is for store the prefix, another t2 is for the suffix. Yeah. Now we can check all the word. So for word in, we can use the dictionary directly, d.case. Yeah, I hope you understand why we're gonna use a dictionary, because basically we only need the maximum index. So for this character A, we're gonna store an index as 2. So we're gonna use this 2 instead of 0 and 1. We don't need to repeat the work. Yeah, otherwise it's gonna be time limit exceeded. We have to solve it first like this. So for this character A, it's gonna store the index as 2. So for this word, this is A. Inside the d.case, I need to get the maximum index because I'm gonna use it. Yeah. So for word in d.case, so self.t1 should insert the word. Yeah, and I also need to insert an index. Because if I just insert the word inside a trie, so for example, I build a trie structure. So this is my trie. I have all the characters like A, B, C. Yeah, or maybe here is another C, here is D. Yeah, I have a basic trie structure, but I don't have the index. I don't know the maximum index. For example, this A, the maximum index may be 5, and this AB, maybe the maximum index is gonna be 2. Maybe for this ABC, the maximum index may be 1. I'm not sure, so I have to store the index as well. This is why I have to put the index, the maximum index, inside the trie. Yeah, it is not so difficult. Let's just try to build it one by one. So we're gonna put the self.insert. We're gonna insert the index as well. So where is the index? It's gonna be the dictionary with this word. Yeah, and similarly, self.t2 should also insert, but the word should be reversed and the dictionary of the word. Yeah, but the index is gonna be the same. We just need to use this word. Yeah, we just need to put it inside the self.t2. For this, for this word, we build it by the hash table. We use a hash table to build it. So we're gonna search it directly, use this word. But while we insert it inside, we're gonna reverse it. Yeah, but this is just the maximum index. So we're gonna directly use this D word. We cannot use the reverse, otherwise it is not inside the hash table. Yeah. Now we need to change a little bit about the method, because currently we use the insert. So if we use insert, we also insert an index. Yeah. Now from here, we need to add another index as our input for the method. We're gonna use an index. But what are we gonna do if we add an index? So if we add an index, basically we need to put the index inside each of the node. Currently, the node only have a dictionary, and the node also have an add of word. It's gonna be true or false. So for our node, we're gonna store another variable. It's gonna be the index. Yeah. So from here, we're gonna store another variable, self.index. It's gonna be from 0. Yeah, it cannot be 0. It's gonna be a set. So this is self.index. It will store a set of maximum indexes, because I'm not sure. It may be 1 or maybe 2. Yeah, maybe it has 2, 3. For the suffix, for this, yeah, because there is a suffix. So for the prefix, maybe it is 2 and 3. Maybe for the suffix it is 3 and 4. And our result is the union of the two. It's gonna be 3 if we can find it. Otherwise, it's gonna be -1. So if we just store a value, it is not possible. we have to store an array of values. But to reduce the time, we can use a has set. Yeah, if we use a set, it's gonna be for each of the node, we're gonna store not only the children and dictionary boolean, but we also store a set. Yeah. Now what are we gonna do? We want to put it inside the set as well. Yeah, we can directly put it inside while we insert it. So we build a new node. So self.index, we can add our index I. So from here, we need to change it. So from here, we need to add this index I. So if we build a new one, we need to add it. If we didn't build it, we didn't update here, but we're gonna update the old ones. We're still gonna update the index. So from here, self.index need to add another new index I. Yeah. So this is why I'm gonna prepare a self.index. It's gonna be a set. Do we need to have this one current.add word? I think this is okay. We can delete it or keep it. This is just okay, just to check if it is the end of a word. Yeah, I think it is okay. Now for the prefix, for this method, we also need to have this. Yeah, we also needed to have the index, I think. Yeah, although currently I didn't use the, yeah, I'm not sure. I don't need to use the index. Yeah, but let me just use it. While I need it, I'll prepare it here. Yeah. So now I think we finished the initialization. We prepared a hash table and we prepare a map of the word with the maximum index, and then we prepared to try, and we put it inside. We insert it inside the try T1 and T2. Yeah. Now I think we can get the result. So let's say the prefix of index set. Yeah, let's use the prefix index set. It's gonna be the self.t1 dot prefix. So this is my method. So I'm gonna prepare a prefix. And similarly, the suffix index set. So I'm gonna use the surf.index set. So yeah, let me just it's gonna be the self.t2 with the prefix, and inside it's gonna be the suffix, but we need to reverse it. Yeah, we have to be careful. A lot of details. Because we build it a suffix, we reverse each of the word while we insert it. So while we search it, we still need to reverse the suffix. Now we need to prepare if there's something inside the prefix set, if some number, and it also inside the suffix. So we're gonna get this number, but we're gonna get the maximum. So I'm gonna prepare a result. Yeah, let me first check it. So if this prefix set may be equal to a -1, or this suffix set may be equal to -1. If either of them equal to -1, definitely I'm gonna return. Let me check the return. I'm gonna return a -1. Yeah, I didn't prepare it yet, but I will prepare. Yeah, definitely. Yeah, for this prefix set, definitely this method gonna return a set if I find it. If I didn't find it, I'm gonna return a -1. So I'm gonna change this false to -1, and here I'm gonna return a set. So it's gonna be self.index. Yeah, let me check for the prefix. Do I need to do any operations about this index? because this index is done in the insert method, while we insert it, basically we're gonna prepare this kind of index. But for the prefix, we just needed to check it. If we didn't find it, we're gonna return a -1. If we find it, basically we're gonna return a set. I think this is okay for the prefix. Yeah. Now we fixed all the method of the insert and prefix. Yeah. So if it equals to -1 or suffix equal to -1, definitely we're gonna return a -1. Now we're gonna set a result as the negative infinity because we're gonna check the maximum of them. Definitely now we have a prefix index set and a suffix index set. We just needed to union them together. Yeah. So for a count inside the prefix index set, if this count is just a number index count, it is also inside the suffix index set. So this means I can check the maximum value. Result gonna be the maximum of result with this count, or maybe the maximum index. Maybe I gonna use I for this index, and if this index is also inside the suffix, so I'm gonna compare with the result and get the maximum for the result. And finally, I'm gonna return this result if this result not equal to negative infinity. Otherwise, I'm gonna return a -1. Yeah. As you can see, it's a lot of code, and it's also testing us how to debug the problem. If it is you write too many lines of code and you are not sure if it is right or wrong. Yeah. Now let me just run it to check if it is okay. Oh, the Trie object has no attribute index. Oh. Yeah, I cannot use the self. This is not a Trie object. I have to use the current.index.add, and here current.index.add. I think it should be okay. Let me just run it. Has no attribute. Where is it? Oh, so here it's gonna be finally I'm gonna return the current.index. It is not self.index. I didn't prepare that. It is my current. I needed to check the current node, and with this index, basically it is a has set. Yeah, now it works. As you can see, I didn't change too much. Basically, it is just a small mistake, I think. But basically, I hope it should work. Now let me just submit it to check if it works. Yeah, now as you can see, it works, and it's pretty fast. I think 1 second is okay for this Trie problem. And while I'm solving this problem, I think I got a lot of time limit exceeded many times, and then I find the reason. That is, I didn't prepare this kind of a hash table. I'm also thinking about it. Maybe the testing case it's gonna be okay, because basically the time complexity gonna be 10 to the power of 8. It can pass maybe for this Trie problem, and because as you can see, the length of the word is 7, and this is 10 to the power of 4, and there will be 10 to the power of 4 cows, so it's gonna be 10 to the power of 8, so 7 times 10 to the power of 8. Yeah, basically it should be okay, because for each of the character it's gonna be 26 different cases, and 26 to the power of 7 definitely is gonna be a very big number. Yeah, but I think the testing case should be okay. But actually I find a lot of repeating word like AA or BB a lot of repeating words, so we have to use a hash table to optimize it, and then we can pass. Even we optimize it, but for the worst testing cases, the time complexity should still be 10 to the power of 8. Yeah, because if there's no duplicate, what if there's no duplicate? If there's no meaning for this kind of hash table? I mean, all the word inside the words is unique. I think it can have the unique because it is 10 to the power of 4, and each word will have the length of 7, and there are 26 characters for each of the character. So it may have no duplicate. Yeah, but anyway, I have to optimize this and let it pass. Thank you for watching. See you next time.